power of the atom, greatest source of energy man has ever discovered, is now serving in many ways, from atomic submarines and ships to nuclear fuel generation of electric power. Planning ahead.
In 1968, nuclear energy was praised as a source of energy that would power the nation. By the year 2000, there was predicted to be 1,000 operating nuclear power plants in the United States. Today, that number is only 63. On the surface, nuclear energy can be easily villainized due to the vast amount of nuclear waste it produces and the accidents that have occurred in the past. But this source of energy is significantly more efficient, powerful, and abundant than other major energy sources. With this, we believe nuclear energy should become a major source of renewable energy in the United States and in other nations, because it is the most reliable and efficient form of emission-free energy production, releases a smaller amount of radiation into the environment than coal and fossil fuels, and has become far safer than what is commonly believed thanks to research and development in the field of nuclear energy and fission. Despite the significant downfall nuclear energy has gone through over the past half-century, nuclear energy still accounts for 20% of the nation's energy. According to National Geographic, nuclear energy is the energy in the nucleus, or core of an atom, where nuclear energy is created in 3 major steps. Based off a chart created by the United States Nuclear Regulatory Commission, uranium is recovered, enriched, then reprocessed. Nuclear energy was first used in 1954 after it was invented by the USSR. The first operating nuclear power plant was built in the city of Obninsk, Russia, about 68 miles southwest of Moscow. When nuclear power is created, a byproduct is also produced. The byproduct created by nuclear energy is unfortunately radioactive. This radioactive material is known to be extremely toxic, causing burns and increasing the risk for cancers, blood disease, and bone decay. Currently, on an annual basis, nuclear energy produces 1,200 to 2,000 tons of waste. Nuclear waste is the main contributor to nuclear energy's downfall. At the time when nuclear energy was first gaining popularity, one common practice that nations pursued was to dump nuclear waste in the ocean. This process was made illegal shortly after it gained publicity. Since then, there have been several different plans that have been proposed to solve this issue. One of the many promising plans is to store nuclear waste in Nevada, under the Yucca Mountains. This ultimately failed, and the federal government since then has ignored the issue. Today, one solution that has gained popularity consists of creating international nuclear waste storage plants. However, the only country currently pursuing this is Finland. After nuclear waste became publicly an issue, investors became uninterested in nuclear energy and returned to more reliable energy sources, such as coal, to invest in. Nuclear waste has also forced several power plants to halt production. This typically occurs after over time nuclear power plants obtain too much waste and are forced to shut down. This issue is still prevalent today, as seen with the closing of the San Onofre nuclear power plant in 2013, which still has 1,700 tons of spent nuclear fuel that is still stored at the power plant. Today, the effort to resolve the issue towards nuclear waste continues, as the Yucca Mountain Plan solution has come back into question among many other possible solutions provided to Congress. Although the byproduct of nuclear energy has proved to be troublesome, nuclear energy does not produce any emissions, which contributes to why it is still used in the United States. This is due in part to the method that nuclear energy endures to transform uranium into electricity.
So how exactly is nuclear energy extracted? The process of extracting nuclear energy is simple when broken down into the 3 steps required to produce the final products. The first step begins with a nuclear reactor core that contains hundreds of fuel assemblies containing thousands of small pellets of ceramic uranium oxide fuel. Heat is produced through a chain reaction created by fission, or splitting of uranium atoms. Step 2 consists of hot fuel rods transferring heat to water that has arisen from the bottom of the reactor. The water is kept at incredibly high temperatures, but is kept from boiling since it's under high pressure, much like a pressure cooker. The heated water is then sent to a steam generator, where it is surrounded by cooler water that boils into steam. The third step in the creation of nuclear energy consists of pressurized water, reactors, and the use of a turbine generator. After turbine generator is put into motion with the previously produced steam, it now causes motion to a magnet coiled in wire. The wire now holds an electric current from the constant flow of electrons, and the process is complete. As stated before, In the U.S., the 63 operating power plants create about 1,700 tons of nuclear waste. This material is very radioactive, and to ensure that it is properly disposed of, it undergoes another kind of process. Nuclear waste is stored in tanks, either using steel cylinders as radioactive shields or using deep and stable geologic formations. These tanks are then placed in concrete storages meant to withstand different natural disasters like earthquakes or plane crashes. The important thing to remember is that this process produces zero greenhouse gases and can run from a couple of years depending on the method of extraction.
Now, nuclear energy has always been plagued with skepticism towards its safety and efficiency compared to other, newer sources of renewable and clean energy. Furthermore, the mass coverage of the Chernobyl disaster in 1986, which killed 59 people, only fueled fears that existed prior. The disaster of Chernobyl ultimately signaled the decline of nuclear energy as a prominent source of electricity due to the profound impact it had on the perceptions of the public. While what happened at Chernobyl was truly catastrophic and horrid, it was also an outlier and a one-off event. While international media began targeting nuclear energy and the dangers it posed, scientists scrambled to reassure the public that the chances of a nuclear meltdown occurring at a power plant were incredibly low. Unfortunately, the public took the word of the popular media, which contradicted the scientists and continued to outline the horrors of nuclear meltdowns and their effects. As a result, public sentiment towards nuclear energy became exceedingly negative. In order to address and resolve the public anxiety, national governments in Europe and in the United States began to roll back their plans for establishing or expanding nuclear programs. In 2016, the Institute for Energy Research stated that in the United States, no new nuclear reactors have been put into operation since 1996. Meanwhile, in Germany, cutting down on the nuclear program meant building more fossil-fueled power stations to make up for the energy produced by nuclear power plants. As a result, carbon emissions in Germany have actually risen. This illustrates how public opinion towards a matter they know so little about has resulted in a complete overhaul of an industry that aimed to move the world away from emission-producing sources of energy. The cutting back of nuclear programs, at the request of the populace, has directly led to an increase in carbon emissions around the globe. Nuclear energy is the single most efficient, emissionless source of energy. It is not limited by environmental and meteorological factors like solar energy, wind power, or hydropower, and can be implemented and generated anywhere at any time. The decline of the nuclear industry at the hands of the common people may very well have contributed to accelerating the global phenomena of climate change and, in turn, the destruction of the world's ecosystems.
Nuclear power plants, as mentioned earlier, are substantially more efficient at producing electricity than more traditional forms of production such as coal, gas, and even green energy. An average coal power plant can produce about 550 megawatts of electricity per hour, which is roughly enough energy to power 5.5 million light bulbs. A nuclear power plant can produce almost double the electricity in the same amount of time. Not only are nuclear power plants more efficient, but they require less material to operate. To operate for a year, a nuclear power plant needs about 70,000 metric tons of uranium. This might seem like a lot, but in comparison to the 3.3 million tons of coal a year used by coal plants, it's quite reasonable. The amount of uranium used is only going down, as methods to recycle used uranium improve. Although nuclear power does have its drawbacks of nuclear waste, nuclear power is basically emissionless. Coal plants emit 1,100 grams of carbon per hour, contributing to pollution and global warming. Now, there are other emissionless power sources such as solar, wind, and water, but these forms of production don't produce energy very efficiently and can't be built anywhere, unlike nuclear energy, which is an efficient source of power and emits little to no carbon.
Despite the controversy surrounding nuclear energy since its creation in 1954, we believe that nuclear energy should be a source of energy that is more commonly utilized among the 31 countries that currently obtain this power. In order for nuclear energy to regain popularity, efforts must be made by the national government in implementing it and educating the masses on how it works, its benefits to the population, and the environment. The government must pass policies to incentivize investors to reinvest in the nuclear energy industry and bring about proper education on the topic if they wish to restore nuclear energy as a driving force for the production of electricity and the battle against emission-producing forms of energy that are destroying our precious planet.